This is Cyber 4220 Server System Security. This is presentation number 4, going over IMAPS and DNS by kburnsid. Okay, IMAPS. IMAP stands for Internet Message Protocol, and just like everything else that we've gone over so far, the S on the end means IMAP secure. The difference being IMAP allows plain text credentials, while IMAPS uses encrypted credentials. Uses the TCP IP connection using the three-way handshake that we went over in previous presentations. So I'm not going to stop and rehash that again. And IMAPS is a set of rules that determines how messages are accessed from server to client. Similar to POP3, the difference being that the IMAP keeps the server copy of the message and allows direct manipulation of messages from the server level. It can delete messages, but only when a set of conditions for the rules are met. The downside is it does use more space than POP3 because you are keeping all those messages on your server. The upside is it allows for mobile pull down and multiple pull down. You can access it simultaneously from all your devices. Just like I have a Google phone, and I access my work emails and my personal emails from my phone and from my desktop and my laptop. Also allows me to share emails and screens with multiple access points, which makes networking really good for large enterprises like where I work, a large construction company. Not everybody's tech savvy, but if I can control what they see, and we're all looking at the same thing, if I can, pull up certain messages or direct them and I'm seeing the same screen they are from a central email that a whole section uses, say safety, and I can go into safety's email box on my message, so I can figure out exactly what they're missing, haven't seen, have seen, what was sent, what's being processed. So it's a give and take whether you're going to use primarily POP3 or IMAPS. Alright, configuring IMAPS. We're going to be using Dovecot to configure IMAPS this semester on our Linux servers. So first, as always, install it, sudo apt-get install. I'm not going to read the whole thing. Configure. Most of the configuration of Dovecot, you're going to be editing the dovecot.configure file, and a lot of it's going to be amending, which is just adding lines into that file. First one being protocols. You have a choice of amending protocols equals POP3, POP3S, IMAP, IMAPS. You can do all, you can do any combination of. I just put in there POP3S and IMAPS so that make sure that both are still running on my server. I may be incorrect when I go to do it. I may not need to have that same line. I may just need to have protocols equals IMAPS, but that was a good starting point. The second amend line is adding a line for where your mailbox inbox will be stored. The third one, once you enable IMAPS, usually plain text authentication is just automatically disabled, but I went ahead and made sure and looked up the syntax for the line to make sure that plain text authentication was disabled. And then after, like anything else, after you install and configure, then you need to test. Start Dovecot, sudo service dovecot start, just like we always do. Check the status. A lot of times I had a problem last semester with my IP tables. For some reason I could start it, enable it, but every time I checked status it was dead. Of course I had to put in the persistent package, which I didn't do it first. But always check the status even after you hit start, still recheck your status. Then do a port check. You can do that using the OpenSSL, which we already have installed, which is the S-Client Connect no domain AXE 993, which is the default port for IMAPS. Default port for IMAP is 143. And then you're going to look for a return message saying OK star Dovecot star ready, and that should mean that it is enabled listening on that port. IMAPS hardening tips, correct port configuration. Default port for IMAP is 143. Once it comes to IMAPS, should be 993 as default. Enable encrypted login, encrypted only login. Like I said, I went back and amended the dovecot file to only allow encrypted, not to allow plain text. Always keep your dovecot agent updated. I'm one of the few, not few, I'm one of the people that always harps on keeping your stuff updated, keep a review schedule, and stick to it. So if anytime you don't keep your stuff updated, you're using old data that's already in the process of being cracked. Like I said before, the main enemy of any cybersecurity endeavor and the main weapon or advantage of any offensive actor is time and computing power. If you're using old data, well, you're using stuff they've already had time to crack. Ensure SSL is enabled on most servers already is, but good hardening tip. Ensure your key file is password protective. Once you have your SSL encrypted and your IMAPS, it's going to generate a key file. Make sure that file is also password protected. So you're password protecting a password file. Configure additional authentication for remote users. If you're using IMAPS and you're allowing people to use their phone or their tablet or whatever to pull or manipulate messages on the server, then make sure that there's an additional authentication means, whether it be a security token, longer password, different password, rotating password, rolling encryption password, some additional step, because as people work remote and get away from a centralized location, you lose control and command of that entity and that device. So you always need to want to have additional authentication on anything that's not under your direct purview. And source I used, Ubuntu, community dovecot. That's the source. We're using Ubuntu, using dovecot, so there's really no better place to get information than the Ubuntu website, especially when it comes to their specific communities for each package or service. There were a couple other places I looked to kind of get some ideas for additional hardening and some steps for installing, just because it had easier access to the direct information I need. I'd have to look through so many pages, but having more sources is always good. All right, DNS. DNS is Domain Name System, directory of domain names and IP addresses, decentralized and hierarchical. Decentralized in the fact that there's multiple servers, multiple master servers, multiple subservers, and even your own server that has information on what these domain names and what their equitable addresses are. It's a phone book. Just like a phone book, you used to open it up, you look for somebody's name or business's name, and you scroll over, and there's their number. The same way you send out a query for a URL, you type www.google.com, and then it sends out a query to a DNS server. It does allow for recursive queries, so if the first server it tries doesn't have a result for you, it'll repeat that query on a different server, and a different server until either it finds a solution or the query times out. But anyways, it sends off, www.google to a domain name server. Domain name server looks through its little Rolodex and says, okay, Google is this IP address. It sends that IP address back to you, back to your device. Your device then uses the IP address with that web server to go to whatever website you were looking for. Honestly, there's pages and pages and thousands of pages on the internet that it's not that complicated of a high level theory, but the technical aspects is pretty impressive, because it's like a 10-step process from the time you look for Google to the time you get that IP address and then go to Google. Configuring DNS with IIS on our Windows server. Start all programs, administrative tools, click configure your server wizard. I really don't think you want to hear me sit here and go through every single step. So you'll have plenty of time to read through the steps, pause the video, go back. Most of the steps are just getting to the configure DNS server wizard. Once you get, just like everything Windows, once you get to a wizard, you can pretty much be blindfolded and half deaf, and the wizard will still walk you through it. So, hardening. Audit DNS zones. Zone is a space of IP addresses, namespace, servers that you and your organization have control of. Also, when you make your DNS server, you can set up zones and groups of IP addresses, subdomains, domains. Can be a whole little family tree. But the biggest thing is that's under your purview, that's under your responsibility. The only way the internet continues to work is to make sure that everyone takes responsibility for whatever they created. So that's yours. Audit it. Make sure that you don't have dead URLs hanging out that are easy prey for somebody to do a DNS poisoning or spoofing. Make sure your IP address, if they've changed, if they have to change, if you've got conflicts, are cleaned up, etc., etc. Enable and update IP restrictions. If you run an enterprise and you've got people with access to the internet and they have downtime, they're going to use it for downtime. So just enable and update your IP restrictions list, whether it be at-risk websites they shouldn't go to, whether it be you just don't want them on YouTube because it's disruptive. But as far as cybersec, usually the first one is the biggest thing, is people going, to whatever website they may go to on their downtime and just not being safe. So make sure you keep a list of these IP addresses. Verify negative caching. All right, this allows a DNS server to retain a record of negative query responses. They look for a website, it didn't exist or wasn't up, was down, it had been blocked through the IP restricted list, whatever. And then if somebody else tries it, then it just automatically says, hey, you can't access this. Usually it's a time-based retention rate, so you don't fill up too much space with this, maybe 30 days, a month, a week, whatever you want to put it as. But it speeds up your server operations. It also doesn't allow so many inroads for DNS spoofing attacks. Configuring DNS with bind. This it's Linux command line. I could have put 3 slides of the command lines just for this, just create different zones, but I'll just give you the overhead. In my sources cited, there's plenty of sources that'll walk through every single part of this. Update your server, install your bind package, sudos apt-get, start enabled named service, and then edit and create your zones. Now for it's Linux, so when you go to IS, Windows with the wizard, does a little more to create the zones for you. Linux command line especially, that works on you to create those zones. Hardening. Disable DNS recursion unless absolutely necessary to receive recursive queries. This can be utilized for a DNS version of a DDoS attack. So just go ahead and just cut it off unless you absolutely positively have a need to receive recursive queries, which we don't. Hide your bind version. The less information makes you less valuable target. Like I said before, the biggest, it's sad to say, but just like when I was deployed, if you looked like a weak target, you weren't up in your turret, you looked tired, the more information you gave to the enemy, more likely they would be attacked. Make yourself a less desirable target, let them go spend their time dealing with somebody else. If you have 2 servers and they've got their information on what bind version they're using versus yours, where they don't have this information, they're more likely to attack the other target, spend their time on the other target instead of yours. Less information you leave, just the better. and then implement a timeout and rescind feature. Just cleans and resets users' cache to avoid cache poisoning attacks. Name our sources cited. For DNS, I just include all the sources in one instead of separating them into two different ones. Security trails is really good. Most of these are just a list of hardening features. The last two are really the install the last one and the third one, or really the configure and install links to see how to configure and install. But still, read the other ones because they have a lot of good hardening recommendations. And that's it. Thank you.